Okay, I thought it would be helpful to post a video about what to do when you have I in the denominator of a fraction. Now, we vaguely know that the reason we don't want to do this is because we know we're not allowed to keep square roots in the denominators, and I is the square root of -1, so it's a no-no for the denominator. One other thing that I'd like to remind you of at the outset here is that I squared equals -1. Those are two facts that you are going to need to know for these processes. So let's keep those in the back of our mind. Now we've got two similar but ultimately different problems here. The one on the left, 3 plus 4i over I, has a more simple denominator. When I have just I in the denominator, I am allowed to multiply the numerator and the denominator by I over I. The reason that this works is it's going to give me a denominator of I squared. I squared is just -1, so I'm not going to have any roots in the denominator anymore. We've got to work a little bit with the numerator here. We're going to distribute. We're going to get 3i plus 4i squared, which, remembering that I squared is -1, is going to give us 3i minus 4. Now, we've got -1 in the denominator, so that's really -3i plus 4. And convention tells us that we should write this in standard form as 4 minus 3i. All told, the one on the left here is a pretty simple problem. The one on the right is a little bit trickier of a proposition because we don't have a denominator that's just I. When we have a sum or a difference in the denominator, we need to multiply by what's called the conjugate. In this instance, because I've got an n number, that it's called a complex conjugate. So I have to multiply both the numerator and the denominator by 5 plus I. 5 plus I. This is a four-line problem in both the numerator and the denominator. So in the numerator, I'm going to get 15, those are my firsts, plus 3i plus 20i plus 4i squared. I'm not going to combine like terms just yet. I'm going to look at the denominator first. In the denominator, because I have conjugates, my outers and my inners are going to cancel each other out, so I only have to worry about the firsts and the lasts. The outers and the inners are going to cancel out. That's why we use the conjugates in the first place. So my firsts are going to multiply to 25, and my lasts are going to multiply to -I squared. I'm going to replace all of my I squareds with -1, and I'm going to combine like terms in the numerator. So I'm going to have 15 plus 23i, and now my I squared here I'm going to replace with -1, so plus 4 times -1. In the denominator, I'm going to have 25 minus -1. So, all told, this is -4, because it's 4 times -1. I'm going to have 11 plus 23i over 26. As with any problem, when I end up with a fraction, I'm going to look to see if that's going to reduce. Do 11, 23, and 26 have anything in common? In this particular problem, they don't. So this could be my final answer. Some people would more traditionally record this answer as 11 over 26 plus 23 over 26i, just splitting my fraction up. I'm okay if you do that. I'm also okay if you don't.